Here we have a SAT math question. Okay, let's go with the information. In the given figure, BC is the diameter of the circle. If the length of BC is equal to 132 and the length of AB is equal to square root of 363, what is the value of BC over BD? Okay, in the given figure, we have to find the ratio between the lengths of the line segment BC and BD. So BC is a part of the triangle ABC and BD is a part of the triangle ABD. So if I prove the two triangles, triangle ABC and triangle ABD are similar, then I'll have a chance to get the values, value of BC or BD by taking the corresponding sides are proportional. Okay, now our aim is to prove the two triangles are similar, ABC and ABD. Okay, for that, let me consider the angle measure at the vertex A of the triangle ABC, the bigger triangle. So we know that angle measure on the semicircle is always right angle. So because BC is diameter, then this is semicircle and the angle measure at point A and the semicircle has to be a right angle, that is 90 degree. Already we know that this is a right angle, it's given in the question itself, and this one also must be right angle. So because this is a straight angle, it measures 180 degree, since it is 90 degree, and this one also must be 90 degree, so that these two angle measures will add up to 180 degree, so which is a straight angle. Okay, now let's consider the angle measure A at the bigger triangle ABC. Let me write the stuff over here. Now I consider the right angle, the bigger triangle A. Now, what is the, at which vertex do we have a right angle in the smaller triangle ABD? So clearly at vertex D, we have the right angle. So let me write the vertex D over here. Now, let's consider the vertex B of the bigger triangle ABC, and the same vertex B we have in the smaller triangle ABD as well. So B is a common vertex for both the triangles. Let me write out here. Okay, now let's consider the two vertices AB over here and DB over here. So we know that in the bigger triangle ABC, we have right angle at the vertex A. The smaller triangle ABD, we have right angle at the vertex D. So A is right angle and D is right angle. And B is a common vertex for both the triangles. So the interior angle measure we have at the vertex B must be equal. So the two angle measures, the two interior angles of the bigger triangle ABC are equal to the two interior angles of the smaller triangle ABD. So by angle similarity postulate, the two triangles are similar. So whenever two interior angles of one triangle are congruent to two interior angles of another triangle, then the two triangles are similar by angle similarity postulate. Okay, now let's complete this stuff. So I have written only the two vertices for the bigger triangle ABC. The third vertex is just C. And for this triangle, I have taken two vertices D and B. The third vertex is going to be A. So let me write over here. So the two triangles are similar. Whenever two triangles are similar, the corresponding sides are proportional. So here, first let me take the side AB. AB means the first letter and second letter over here. And what is the corresponding side in the second triangle? We have to consider the letters of the same question, then DB. So DB, or it can also be written as BD. Now let me take the side BC, second letter and third letter. Now the corresponding side in the second triangle is also the letters of the same question, B and A, or it can also be written as AB. Now let me take the side AC, first letter and third letter. The corresponding side over here is DA, or it can also be written as AD. Okay, now let's plug in the lengths. Already we know that AB is the length of AB is square root of 363. Let me write it. And the length of BD is not given, so we can write BD as it is. And the length of BC is given, that is 132. Let me write it. And the length of AB again square root of 363. And for AC, I do not know the length. For AD also, I do not know the length. Since I do not know the length for AC and AD, so we can ignore this particular ratio. So now in this proportion, because two ratios are equal, it's a proportion. So in this proportion, I have to solve for BD, which is unknown. So once I get the value of BD, and already I know the value of I know the length of AC, which is 132. So I'll be able to get the value of this ratio. Okay, now let's solve for BD in this proportion. So for that, I'm taking reciprocal on both sides, because if I want to solve for BD, it has to be numerator. So if I take reciprocal on the left side, I'm getting BD over square root of 363. And if I take reciprocal over here, I'm getting square root of 363 over 132. Okay, now let me multiply both sides by square root of 363 to solve for BD. Let me do it. So this square root of 363, square root of 363 will cancel. I'm getting BD on the left side. Okay, here on the right side, if I multiply square root of 363 and square root of 363, I'm just getting 363 over 132. Okay, I think both of them can be simplified. I mean, 360 and 132 can be simplified using 3 times table. So 3 goes into 363 1 times, 2 times, 1 times. And here 3 goes into 13 4 times is 12, and we have 1 left over here. If I take this one along with the next digit 2, it will become 12. Again, I'm getting 4. Now, 11 goes into 44 4 times, and 11 goes into 121 11 times, because 121 and 44, both of them have the common divisor 1104. So 11. Okay. Now, so BD, sorry, 1 second. BD equals to 11 over 4. I got the length of BD. Okay, our aim is to find the ratio, value of the ratio BC over BD. Let me write that. 1 second, let me change the color. So BC over BD equals to, so already we know the length of BC, that's given in the question itself, that is 132 over the length of BD, just now we got it, that is 11 over 4. Let me write it. Okay, now we can write this numerator 132 as it is, and we can change this division as multiplication and take reciprocal of this 11 over 4, then it will become 4 over 11. Okay, 11 goes into 11 1 times, and 11 goes into 132. Let me check. 11 goes into 13 1 times, and we have 2 left over, 22, because if I take the 2 along with the next digit, it will become 22 and 2 times. Anyways, 11 goes into 132 12 times. So now 12 times 4 is 48. So therefore, the value of the ratio BC over BD is 48.